NASA's lunar flashlight to hunt for water in ancient moon craters. NASA is planning to launch a tiny satellite aboard one of the most powerful rockets ever constructed, to hunt for ice hiding deep inside inky black impact craters on the Moon's surface. The bottoms of these craters, which are located near the lunar poles, have never felt the warming touch of sunlight, and so are the perfect place to search for water ice. The space agency's next great adventure is to put the first woman and the next man on the Moon. Despite the fact that humanity first visited the lunar surface in 1969, this is still an incredibly challenging and expensive prospect. One way that NASA is hoping to cut down on mission spending and make the endeavor more viable is to harvest and use resources already present on the Moon. In particular, space agencies around the world are exploring the possibility of mining water ice, which could be converted into drinkable water, oxygen, or even rocket fuel with the right equipment. Although we have a pretty good idea there's ice inside the coldest and darkest craters on the Moon, previous measurements have been a little bit ambiguous, comments Barbara Cohen, principal investigator of the mission at NASA's Goddard Space Flight Center in Maryland. Scientifically, that's fine, but if we're planning on sending astronauts there to dig up the ice and drink it, we have to be sure it exists. Enter NASA's Lunar Flashlight satellite, which is due to ride shotgun as a secondary payload when the Artemis I mission launches atop NASA's Block 1 SLS rocket. The probe belongs to a class of satellites called CubeSats, which are defined by their relatively tiny proportions and modular design. The Lunar Flashlight spacecraft will measure a mere 12 by 24 by 36 centimeters, 4.7 by 9.4 by 14.1 in. CubeSats come with several drawbacks due to their limited volume, however they are proving to be incredibly versatile, especially when it comes to testing technologies that can then be incorporated on later flagship missions. They are also cheap to produce, and don't require a dedicated launch vehicle to get to orbit. The 14-kilogram 31 lb spacecraft will be powered by solar panels, and propelled by 4 thrusters that draw on a new environmentally friendly propellant. Its main scientific instrument is a 4-laser reflectometer, that will be used to probe the depths of lunar craters. Over the course of 10 orbits spread out over a 2-month primary science phase, the tiny spacecraft will zoom within 15 kilometers (9 miles) of the lunar south pole and take its measurements. The floors of the craters that will be explored by the lunar flashlight are sheathed in perennial darkness. The sun moves around the crater horizon but never actually shines into the crater, explains Cohen. Because these craters are so cold, these molecules never receive enough energy to escape, so they become trapped and accumulate over billions of years. The probe is designed to rapidly fire infrared laser beams into the Moon's craters and then collect the light when it bounces back. The soil that covers the Moon's surface, known as regolith, doesn't absorb infrared light, however water ice does. Therefore, the greater the amount of absorption from a lunar crater, the larger the quantity of ice that could be hiding there. Once the lunar flashlight has completed its mission mapping ice distribution in lunar craters, it will be commanded to end its life by smashing into the Moon's south pole. Thanks for watching. Don't forget to subscribe.